Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a fake gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So, regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least, we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here. First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet. And with it, it also attracts our arrow of time. That means it slows the time down. And the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. because now it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first?
You might have run into a black hole and not even know it. No, not a real one, like those that are in outer space, but an internet black hole. It can happen when the website you're trying to access doesn't load, or your email seems to get lost forever in cyberspace, never reaching its destination. A research team at a famous university in the US started looking at this phenomenon, and what they found was amazing. For starters, the situation of things getting lost on the internet happens way more often than you think. To help with identifying these internet weak points, researchers have put together an online interactive map, which updates every 15 minutes. On this map, online black holes are pointed out with red flags. If your message fails to get through to your friend while you're emailing each other, it may be because your wireless network has some sort of error, or even because a specific server is momentarily going down. Those are the simple, explicable cases. Others are more mysterious and harder to piece together. At this precise moment, a lot of messages all over the planet are lost to online black holes. Think about it this way. All information sent across the internet moves around like packages, being transported from one area to another, even to the remotest corners of the world. Most people have experienced getting something they've ordered lost in the mail, a letter or a package. It may get destroyed, or it may even fall off from the delivery vehicle when it was loaded during transportation. Either the transportation company or the seller usually takes the loss, simply refunding you the money you've spent or resending the product. It's the same with information online, only in this case, we have no idea where it goes once it gets lost. Here's how the interactive map works. Researchers send test messages across the globe to look for computers that can be reached. Short communication failures are ignored. These sort of problems become black holes when they fail to respond within 15 minutes. Overall, the research uncovered that more than 7% of computers all over the world experienced this type of error at least once in 3 weeks. Did this map help manage to figure out what internet black holes are? Not really, but it is a first step in uncovering the mystery. So far, it's been most useful for professional network operators who really need to keep the internet running smoothly. Another one of those internet sensations was that of the story of the most mysterious song on the internet. And it goes back to 2007, when a person posted a clip of a song on a Canadian radio station fan site. The same comment stated that the song was recorded from a German radio station some time back, but had no idea who the singer was, or how old the song may have been. The tune itself didn't help much either. It had a simple beat, monotone vocals, and sounded very similar to most 80s hits. It sounded familiar, but at the same time, it was really hard to pinpoint where it might have come from. The information about this song spread like wildfire on the internet, but at one point, no one knew who wrote it, who sang it, or even when it might have come out. It wasn't long until most music aficionados on the internet started calling this the most mysterious song on the internet. The person that initially posted the comment joined the search eventually, saying that it was her brother that recorded the song from a radio station years prior. He thought the song was nice and hoped it would be replayed eventually so that he could find out the name of the artist. That never happened. Over the years, countless people have tried to claim ownership of the song, but they've all been proven as fake. Some have even thought that the original post, looking to find out who the singer was, had no other purpose than to draw attention and create a frenzy online. To this day, no one has yet to figure out the author of that song, but communities online have helped a lot of people ever since this first case identify their favorite lost tunes. Other internet mysteries are way creepier. In June of 2011, a young man named Frank passed away suddenly from a heart condition. 5 months later, his best friend Tim started receiving emails from him with a weird subject line. It simply said, "I'm watching." Apart from the intriguing intro, the email also contained information that only the two men could have known. Sometime before, they were both in Tim's attic, having a conversation about what to do with that space. As far as Tim knew, no one else heard that conversation. Weirdly enough, the email urged Tim to start cleaning up his attic so he could finally use it. His best friend wasn't the only one that received emails from the beyond. Frank's cousin also received a message from him, talking about a broken ankle. Surprisingly, his cousin really had injured his leg a week prior to receiving the email. To this day, no one knows who sent those emails. As far as his friends and family know, nobody had access to Frank's computer or passwords. Most of them didn't believe his account might have been hacked either. If you're a fan of internet unsolved cases, you've surely heard of the name John Titor. It all started back in 2000, when a user under this name started posting information on the internet one day, claiming he was a time traveler. He claimed to be from the future, and went on to make some predictions about the future. For starters, John Titor said that he was a soldier that came all the way from the year 2036. In this specific year, apparently a computer virus had already destroyed the world. The reason why he came back was to retrieve a 1975 IBM computer, which was crucial for saving the world from the virus. Technically, he didn't need to travel to the 2000s, but he made a short detour because he wanted to visit his 3-year-old self. Over the course of a couple of months, this user answered every question people threw at him, describing the future in a very cryptic manner. He always made sure to add a disclaimer to the information he provided, stating that alternate realities do exist, so his rendition of the future might not be the one bound to happen. The most obvious question people asked was, how did Titor manage to time travel? Throughout his many replies online, he gave people a series of technical specifications on how time travel ends up working in the future. He also provided complex algorithms and even pictures of the machine. The photos were really bad quality though. Will cameras get really bad in the future? Hard to believe. At some point during his online existence, John Titor simply stopped posting. His followers were quick to assume that he might have finished his mission, and that he had to travel back to the future to save humanity. After he disappeared from online forums, a lot of people claimed to know what was behind the story. A journalist was even contacted by 2 different people claiming to be John himself. Both were a tad bit offended they weren't contacted in the first place for an interview. The weirdest of them all is probably the story of a woman claiming she had been John Titor's girlfriend when he traveled back to 1975. Their relationship even produced a boy, which, if you think about it, was technically born before his father. Most of the things John Titor predicted did not happen. So why did his story become so popular? Out of sheer luck, some would say. The internet is filled with all sorts of weird stories, mysteries, and hoaxes. Some of them get enough attention that they get rapidly spread throughout the internet, even if there is no proof. And some people believe they are real.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.